All right, this is the third and final video of going through our Chem Unit 4 test. Number 32, the ions of calcium and phosphorus react to have the formula. We're going to switch her up, so we're going to get calcium with a 3, okay? And now I have my PO4, which is a polyatomic ion, so I'm going to put that in parentheses with the 2 out in the back. And that is going to make our answer. Always got to take a look at them, which is going to be letter E. The formula for ammonium carbonate. Ammonium is NH4 with a 1 plus. And carbonate is a CO3 with a -2. Go ahead, do a switcheroo. So we're looking for NH4 in parentheses with the 2 and CO3, which is going to be letter, gotta make sure I find the right one, letter A. 34. The correct name for this one, again, take a look at that first element. It is a nothing special, so we're just dealing with the magnesium chlorate, which is letter A. What is the correct formula for ammonium sulfide? Again, NH4 with a 1 plus, sulfur is a 2 minus, so we are looking at letter C. Making sure that is actually the right answer. Yeah. Which formula and pair is not correct? Here we go. This should be manganese 2 nitrite, which it is. So nope. Next one should be magnesium nitrate, which is what it is. So that's no. C would be manganese 2 nitrate, which it is. And then we have magnesium nitride. This is nitrite. I need it to be an IDE. So that means that this lovely one is the one that is incorrect. Which one is incorrect? So we should have iron 2 sulfate. That is what it is. We should be dealing with iron 3 sulfite, which is what it is. C, that should be iron 2 sulfide. Nope, that's right. This should be iron 2 sulfite. That's not it. And this should be iron 3 sulfate. That's not the right ending. The correct one is letter E. Okay. Next page. Okay. The formula for aluminum hydroxide, so Al with 3 plus, OH with a 1 minus, so AlOH 3, and so that is letter D. The ionic compound, okay, more than one atom there. There's your key for a polyatomic ion there. We've got ammonium and also phosphate, so we're dealing with ammonium phosphate, which is letter A. The correct name for this one is, again, take a look at that first element. That's a transition metal, so we need Roman numerals. I'm just going to simply do the switcheroo backwards. So we have Cu, parentheses, Cn, parentheses 2. Going to go ahead and take this 2, and that comes up from the copper. So we're dealing with copper 1, and cyanide is the answer. So copper 1 cyanide. Oh, that is not copper 1 cyanide. That is not right. I'm sorry about that. It should be letter D. Okay. 41, covalent compounds occur between elements with which of the following? We share for covalent, letter B. 42 is probably something you did not cover, and we did not cover it in the review. You are not responsible for that question, okay? But what you do for that, okay, is you take your 2 elements, okay, go to the periodic table, and whichever one, okay, the closer they are together is a non. So if we're looking for polar, we want to look to make sure which one is the furthest apart from one another. Okay. Again, you don't have to worry about this. The correct answer is D though. The correct name for P2, again, take a look at the first element. We're dealing with a non-metal. So that means prefixes for this one. So we're looking for diphosphorus pentoxide. Diphosphorus pentoxide, letter C. The correct name for dinitrogen tetraoxide, again, prefixes tell us how many atoms there are. So we're looking for N2O4. Letter B. Almost done here. 45. Which of the following does not have covalent bonds? Covalent bonds are between a non-metal and a non-metal. Okay, so I'm looking for something that has a metal because that would not be a covalent. And I'm going to look at the first element. Okay, hydrogen, non, sulfur, non, potassium is a metal. Phosphorus is not. So which one does not? Letter C, because it has a metal. Simple as that. How many electrons are in a single covalent bond? How many electrons does it share? So in our example that I gave you on the board, okay, fluorine has 7, so does another one, okay? And these 2 electrons are shared in there, and there's 2 of them, one from one another. So how many electrons does the line represent? 2, letter A. Okay. All right, number 47 involves this picture up here, okay? And we're determining the IMF, the interaction, okay? So we start off here with a nice, simple, symmetrical things. This is a non-polar molecule, okay? But here's what happens, okay? I bring in this nice thing, okay, that comes in, okay, this giant thing. And what happens is I go from a non-polar, and now I have these wacky symbols, which is now the lovely dipole. So we start with something, nothing special, and we create something that's got partial positives and partial negatives. So I am inducing something. So I am looking at letter D on that one. This one, okay, the IMF, okay, I've got my 2 wacky symbols on one molecule, so that this is a dipole, and this one is also a dipole. But now I have to make a distinction whether or not it stays dipole-dipole, or if it goes into a hydrogen bond. Hydrogen bonds are between HF, HN, and HO, okay? This one is chlorine going to hydrogen. So that is not any of those, so we're going to stick with dipole-dipole as letter B. Last 2, and then we're done. Okay. Identify the intermolecular force, okay? I come in here and I take a look at the actual charges and what's happening, okay? I've got just a plus charge, okay? When we don't have any of that, sorry, you can't see. When there's nothing of those delta positives or delta negatives, this is just an ion. That's it, okay? And then I have my lovely partial positives or wacky symbols here. That's a dipole. So I'm looking for something that's an ion dipole, which happens to be letter A. And last question that we have here, identify the intermolecular force. So I've got a dipole and another dipole. So we know for sure that this is, in fact, a dipole-dipole. But now check to see if it is a hydrogen bond. And we are looking at oxygen and hydrogen, which is, in fact, one of those 2 special ones. We're dealing with a hydrogen bond. And that takes us all the way through our Unit 4 test. Hopefully this makes a little bit more sense. Obviously, if you have a question on any of this, please ask and I will help you get the right answer. So good luck on your studying.